In this chapter, we talk about how to solve a nonlinear equation. Here, we use numerical methods. We use numerical methods for solving nonlinear equations. We study three methods for solving nonlinear equations, okay? In this chapter, we talk about here these three methods for solving a nonlinear equation, okay? It's only an introduction. For solving a linear equation, look, this one. This is a linear equation. As you see, the degree of x is 1. And it's not angle for sine, cosine, for any other function. Okay? Look, this function is called a linear function. It's a linear function. It's easy to solve a linear function. You just need to find the value of variables here. What's our variable here is x. To solve this, we just equal the function to 0, and then we find the value of x. It's easy. We just need to solve this equation. It's easy. We just equal to 0 and then find the value of x. The value of x here is called the solution for the given linear equation. Okay? And here, as you have this equation, it's a nonlinear equation. It's a quadratic equation. As you see, the exponent of x here is 2. It's not 1. We have exponent of 2 as well. We just equal this to 0. We get this equation. Now, we solve this. We need to factorize this, or this one. Okay? We just factorize this by making it into 2 brackets. Okay? We are going to make it into 2 brackets. We get this. Then we get 2 values for x. One is 2 and the other one is 3. So these two are both solutions for the given equation, for the equation above. Okay? These two are both solutions for the given equation. That's how to solve an equation. But for higher degrees and also for nonlinear equations, we cannot solve it, and we cannot find the exact solution. What we do in that case, we need to use a numerical method. And here in this chapter, we just study 3 methods for solving nonlinear equations. We just studied 3 methods, which are bisection method, secant method, and also Newton method. We have these 3 methods for solving a nonlinear equation. As you see, these are nonlinear equations, and it's difficult to find the solutions here as an exact solution. What we do, we use numerical method for finding approximate solution. And it's also, we cannot factorize it. Okay? So it's difficult to find the zeros for this equation. What we do, we use one of the numerical methods. For the nonlinear equation, by using numerical methods, we have 2 kinds of numerical methods. We have 2 kinds of numerical methods for solving a nonlinear equation. We either work on an interval or work on a fixed point, okay? Here, to work on interval iteration methods, we have this method. This method, we have only bisection method, which works on interval iteration, okay? We have bisection. And also, for point iteration, it works on points, okay? We have these 2 methods, secant method and Newton's method. This one works on 2 points, 2 successive points. the second method works on 2 successive points, but this one works on only 1 point. Okay, it's iteration to find the next point, the next point, like that. Okay. In solving examples, it will be much clear how to use these 3 methods. First, before we talk about the methods, we need to know what's intermediate value theorem. What's intermediate value theorem? We use intermediate value theorem for finding the interval of the solution that you work on by using bisection methods. Okay, so we need to first find the interval of solution, then we apply the iterations by using bisection method to get the solution, to get the approximate solution or the required solution. Here we say for intermediate value theorem, we say if we have 2 points, let's say AB, if we have this interval, okay, and we have a function f of x. We say if f of a times f of b is less than 0, it means between a, b, we have a solution for the function. Okay? We say if f of a times f of b is less than 0, that means the image of one of them is negative and the image of the other one is positive. We say between a and b, we must have at least a solution. Okay? As you see here, this is the, let's say this is a and this is b. Okay? F of a is here. Is it positive or negative? It's above x-axis, so it's positive. And f of b is here. This is f of b. Is negative or not? Yes, it's negative. The multiplication of f of a and f of b is negative, is it? It is negative. That means the graph of f changes from positive to negative, from point A to B. That means at a point between A and B, the graph intersects x-axis. So at this point, we have solution. Okay? Look. How many solutions do you have for this function? 1, 2, 3. Because it intersects x-axis 3 times. Why do we say this is a solution? Because in this side, the graph is positive. And in this side, the graph is negative. Okay? That is, if we pick any point here and any point here on the graph, their multiplication is negative. And how about here? Here it is positive and here is negative. Even here it is positive and it is negative. That means if f of a times f of b is negative, means there is a solution between a and b. Okay? And even here, we say if f of a is less than 0, this is f of a. And if f of b is greater than 0, then their multiplication f of a times f of b is less than 0. That means between a and b, in the interval AB, we have a solution for function f. Okay? We have a solution for function f. Here, intermediate value theorem says that if on an interval f of a times f of b is negative, that means if f of one of the endpoints is positive and f of the other endpoint is negative, that means their multiplication is negative. So it says between a, b, we must have at least a solution for the function. Okay? Look at this example. It says using intermediate value theorem, check whether contains real root in interval or not. But here the function is x squared plus 2x minus 1. Is it? Yeah. It says by using intermediate value theorem, check whether at each of these intervals, do we have a solution for this function or not? What we do for the first interval, we just test them. We don't need to solve it, okay? We just test both endpoints, okay? What we do, we find for the first one. Let's do it. For part I, it is -1 and 0. We need to find f of -1 and f of 0, okay? If their multiplication is negative, means we have a solution. Intermediate value theorem says that. If not, if their multiplication is positive, we say there is no solution for the function on that interval. Let's try this. From this one, we need to find f of -1. What's f of -1? We just plug this point into this function. F is given. So you just replace x by -1 in the function of f. We get -1 squared plus 2 times -1 minus 1. This equals to what? -1 squared is 1. 2 times -1 is -2 minus 1. This is -2. The result is -2. That means f of -1 is f of -1 is -2. Okay? And then let's find f of 0. F of 0 is, if we plug it to this function, we get 0 squared is 0, plus 2 times 0 is 0, then -1, and is -1. So this is f of 0. Now, we just found the image of both endpoints in the function, okay? So f of 0 is -1. And so we say f of -1 times f of 0 is -2 times -1. It is 2. Is it less than 0 or greater than 0? It's greater. So we have no solution in that interval. Okay? This is greater than 0. We say by intermediate value theorem. Okay, IVT. By IVT means intermediate value theorem. We say there is no solution for f of x on -1 and 0. We say there is no solution on the interval. Okay? It's all about the first one. Then for the second one, we do the same. For the third, the same. Okay? Only the intervals change. Look at the second one. It is 0 and 1. 0 and 1. This is double I. Okay? For this one, we need to find f of 0. F of 0, we already found that it's -1. Okay? F of 1 is, look, what's f of 1 here? We just replace x by 1. We get 1 squared plus 2 times 1 minus 1. Okay? It is 1 squared plus 2 times 1 minus 1. And it is 2. Is it? We now have f of 0 and f of 1. Now we multiply those two values. We say f of 1, f of 0 times f of 1 is, f of 0 is -1 times f of 1 is 2. It is -2. So it's less than 0. It is less than 0. By using intermediate value theorem, we say there is a solution. There is at least a solution for the function in the interval 0. Okay? We say by IVT, there is at least a solution for f of x on 0, 1. Look, on negative 0, negative 1, 0, we have no solution for the function. But on this interval 0, 1, we have a solution. Okay, we at least have a solution. And for this one, we do the same. Okay, for 1 and 2, we do the same. It's applying intermediate value theorem to check whether interval contains a real for a given function or not. Okay, it's easy. It's so easy. Just check both endpoints. Find f of endpoints, then multiply them. If it's positive, there is no solution. But if it's negative, we say there is a solution. That's the solutions. Then we have bisection methods. It's the first method that we use for solving a nonlinear equation to find its approximate solution. Okay, here bisection method works on an interval, but the other two methods work on points. Okay, here in bisection method we must have an interval to work on. Yeah, it works on interval iterations. We just find a new interval, then new until you get the approximate solution. Here, we need to check the intermediate value theorem first. That means we must have an interval, which includes a solution for the function. Okay? Here, we must have a solution A. So we must have an interval AB such that f of A times f of B is less than 0. That means the interval must satisfy intermediate value theorem. And then the root can be obtained through midpoint of AB, which is, so the midpoint of AB is A plus B dividing by 2. That's A plus B dividing by 2. We find that midpoint. Then, after finding this, let's say it's A, this is B, okay? We find C. C is the midpoint of AB. You see, C is A plus B dividing by 2. Okay? C is here. We now have two intervals, two new intervals. As you see, we have this interval and this interval. We need to choose one of these two intervals to the next iteration. Okay? Which one do you choose? We need to find f of c. F of c. We need to find f of c. If f of c times f of b is less than 0, so this is our new interval. But if f of c times f of a is less than 0, this is our new interval. Okay? That's how to find the new intervals in each iteration. Okay? Here we say if f of a, this is a and this is b. If f of a is, let's say, negative. If f of a is less than, do you see that? Okay. if f of a is less than 0 and f of b is greater than 0. What we do? We need to find the midpoint first. In the first step, what we do in the first iteration, if this is a and that's b, we need to find c. C is a plus b divided by 2. This is c. So you have only 3 cases for c. We have only 3 cases for c. It's either f of c is 0, or f of c is negative, or f of c is positive. We only have these 3 cases for c. We have no more cases. Okay? If it is 0, that means c is the solution. If it is 0, we say c is the solution. But if it is not 0, it's either less than 0 or greater than 0. If it's less than 0, so what's our new interval? Is it this or that one? Look at f of a and f of b. F of a is less than 0. F of a is less than 0. If you take it with a, let's say this is our new interval. We either take this interval or this one. Okay? We only take one of these intervals. Look, we said f of a is less than 0. F of b is greater than 0. We look at f of c. We said if it is 0, c is the solution. So we have no any more steps. Okay? But if it's not 0, it's either positive or negative. If f of c is less than 0, it's that case. So what's our new interval? We say f of both endpoints, one of them must be negative and one of them must be positive. Okay? If we take it with this, both are negative, is it? Because f of a is negative. F of c is negative, so there is no solution there. We don't take that interval. What we do, we take this interval. Why? Our new interval is CB. Has it satisfied the intermediate value theorem or not? F of C is negative. F of B is positive. Their multiplication is negative. So our new interval is CB. Then again, for this interval, we find the midpoint. Okay. Even in this interval, we find the midpoint again, and we test this point. If it's positive, we take it with the negative one. If it's negative, we take it with a positive. Okay? What if f of c is greater than 0? What if f of c is greater than 0? Our new interval is A and C. Second, let's check it. كذا سي دوزينو سي بريتيرتشي أي زائد بدا بشيتو كأن ما ندوزيوه اف سي دوزينو بلام ام بي اتش تي اف اي بي ما ندوزيوه توا ازاين كاميان موجبه كاميان سالب ونيا اف سي اگر موجبو لغا سالبه كيا انترفالك تازه موجب اگر سالب و اف سي لغا موجبه كيا سيمبوكات انترفالك تازه موجب انا عندي بردوام بي هتا او كاتي solution كيف يدوز يكسر عليه وحلك لأن نخلي يكسر عليه وحلك. Look, C is A plus B over 2. We always use this formula for finding new C. Okay? We now have examples that will be much clearer. Look. We say epsilon should be given. Epsilon is the rate of error. It should be given in the example or in the question. It says, stop when the absolute value of the function at a point which is less than this. So f of xk must be less than epsilon. And also, you can use this if the length of the interval, is less than epsilon, we say xk plus 1 is our solution, the big one. Okay, or the last c that you found is the solution. That's nothing. Look at this example. It says, supposing you have f of x to be this function. We cannot find the solution for this function as an exact solution. What we do, we use numerical methods. The root is obtained through bisection method. Look, it's given that we need to use bisection method that lies in the interval, even if it's not given that use bisection method. As we have interval, you should know that we should use bisection methods. Okay, here only bisection method works on an interval. Okay, if we have an interval, means we need to use bisection method. But here it's mentioned that use bisection and approximates 2 decimal places of accuracy. When it says 2 decimal places, this is value of epsilon. Epsilon is, always write down like this, 0.2 decimal places, 0.005. Okay, let me check if that's 0.05 or 0.05. Look, if it says to 3 decimal places, we say epsilon is 0.0005. If it says 4 decimal places, epsilon is 0.4005. Okay? Always write down 5 at the end. Okay? This is how to write down the value of epsilon. In this example, it says to 2 decimal places. That means epsilon is 0.005. We now need to first check that if this interval satisfy the intermediate value theorem or not. It must satisfy. We say we must have a solution in the interval, then we apply the bisection method. How to check if we have a solution in that interval or not for that function? We need to find f of 0 and f of 1. If one of them is negative and the other one is positive, means their multiplication is negative. And by using intermediate value theorem, we have a solution. And then we apply bisection. We must first check that and then apply bisection method. Look, let's find f of 0 and f of 1. F of 0 is, this becomes 0, this is 0, this is, so you get -5. How about f of 1? this becomes 1. This is minus 3, 1, minus 3, 8, negative 5. These are cancelled out, you get 1. It's positive. Okay? Now, f of 0 times f of 1 is what? F of 0 is negative 5 times 1, which is negative 5. Is it less than 0? Yeah. So it satisfies the intermediate value theorem. That means we have a solution for f of x. On the interval 0, we have a solution for it. Now, we apply bisection method. You must first check it and then apply the bisection. So if this is positive, if both are positive or both are negative, means we have no solution in that interval. So you don't need to apply the bisection method. Just say on the interval we have no solution for the function. That's it. Now, to apply the bisection method, our first interval is 0, 1. Let me write down the function here. X cubed minus 3x squared. This is our function. And our interval is 0, 1. We tested that. And we know there is a solution on that interval of the function. Because f of 0 times f of 1 is less than 0. And f of one of them is negative and the other one is positive. Now, we apply the bisection method. In bisection method, what we do, we need to find new intervals at each iteration. In the first iteration, we need to find the midpoint of the given interval, and then we choose the correct new interval. We say C is A plus B over 2. What are A and B here? A and B are 0 and 1. Okay? A and B are the midpoints of our interval. So this is A and this is B. This is A and this is B. Those are A and B. And equals to 0 plus 1 dividing by 2, which is 0.5, is it? It's 1.5. So it is 0.5. Now, let's find the new interval. But here, we already found that f of 0 is negative. Is it? We found that. And f of 1 is positive. Okay? How to find the new interval? Look, we have 0, 1, 0.5. We must either choose this or this. How to choose? We need to find f of 0.5. F of 0.5. Let's find it. You can use calculators during exams. Okay? Just plug 0.5 into this function and let's see what you get. Let me check. F of it's negative, as you see. F of 0.5 is negative. Let's return here. We say f of 0.5, f of 0.5 is negative. So what's our new interval? Is it 0, 0.5 or 0.51? Which of them? 0.5, 1. Yeah, because f of 1 is positive and f of 0.5 is negative. We take it with the one which has opposite sign. Okay, so our new interval is 0.5 and 1. This is our new interval because f of this is less than 0 and f of this is greater than 0. We say it's not our new interval because f of both are less than 0. So you have no solution in that interval. we have no solution for the function in that interval because both have the same sign. They must have, both endpoints always must have different sign, opposite sign, okay? Let's find new C. Let's check. And then we find f of 0.5, which is negative 1 point something. Let's say 2, 3, 4. It's less than 0. Okay? But you already found that. F of A, which is f of 0. F of 0 is negative. F of 1 is positive. Okay? This sense f of 0.5 times f of 1 is less than 0. So the new interval is 0.5 and 1. Now, for the next iteration, what we do, we say we find a new C. We find a new C. What we do, we work on this interval. We find the sum of them dividing by 2. Okay? We say it's 0.5 plus 1 dividing by 2. It is 1.5 dividing by 2, which is 0.75. Okay? It's 0.75. This is a new C. Now we test this. But be careful here, always from the previous step, you could get that. Look, this is negative. F of this is negative, and f of this is positive. We need to find f of 0.75. F of 0.75. If it is negative, so what's our new solution, new interval? It is 0.75 and 1, is it? But if it is positive, our new interval is 0.5 and 0.75. Let's check if it is positive or negative. That's it. It is negative. F of 0.5 is negative. Okay? By using calculator, you can get the result. Okay? Takes time, that's why I'm not doing it for all iterations. Here, f of 4.5 is negative, but our interval, our last interval is 0.5 and 1. F of 1 is positive. F of 0.5 is negative. We already found these. Okay? So here we have 0.5, 1, 0.75. So what's our new interval? Look at f of 0.75. Is it negative? Yeah, it's negative. This is negative. We take it with a positive. Okay? We take it with the one which has a positive image. This one. So it's 1. So our new interval is 0.75 and 1. Then we will be continuing. Okay? Our new interval is, let me write down here. Our new interval is 0.75 and 1. Okay? Then, but we do the same as we did in the first step. You need to write down since f of, sorry. You need to write down these all. This is the first step. Sorry? Essa بتعمل chaos. essa بتعمل بس ما كل السنة كاتي absolute value انت يرفع لك عم تكتب بين absolute. We now have next step and so look here. We have 7 steps, 7 iterations here. This is 7 iteration. We say if f of c of the last c that you found, f of c is less than the epsilon, it was given that epsilon is 0.005. It says 2 decimal places. It says 2 decimal places, okay? Here, this epsilon is 0.005 because it says 2 decimal places. So we have 2 zeros and then 5. If it says 3 decimal places, we have 3 zeros and 5. And so if f of c is less than this value, we just look. This is f of the first c. Look, second, third, fourth, fifth. None of them is less than 0.005, but this one is. Okay? This is less than 0.005. That means we stop here. If f of c is less than the error, the epsilon, means we just stop there. Okay? So that value of c is our solution. The value of c becomes the solution. Okay. You get that? It's easy. زور يواشني بس أسانج ونيا إذا بيسان يوي وزور نات يعني نات بتستيق بو شيء كوا نات يعني ديتو باريس سيت شوار ستيبسات قزام حوداني إيوا إساو سكن دي بران ساقة بها تايو أمين ترفع علي بيد أنا أتا أوبن حوت أوبن هشي بيبانا بس دو ستيبس يستيرو يدانجو يعني بو الشواب الامتحان ناعد دستيب بلد we find f of that, f of 0.75. Look, our function is this. Let me check. This one is. This is our function. F of 0.75 is 0.75 cubed minus 3 times 0.75 squared plus 8 times 0.75 minus 5. The result here is negative. Okay? We always plug to the function. Vale? That's it. We now have another method, which is secant method. Let's change it. The new method, the second method here, is called secant method. In this method, we work on 2 points. Okay? We work on 2 points. We must have given 2 successive points. Then we find the third one. And then from the last 2 points, you find a new one. Always we do this. Okay? Here, you must have 2 points. Let's say x1 and x2. x1 and x2 are given. From these two, we find x3. Okay? We find x3 from x1 and x2. By using the formula, we can get x3. And always from the last two, we find the next one. We find from x2 and x3, you find x4. And from x3 and x4, you find x5. And from these two, you find x6. And so we always use the last 2 points to get the next points. Okay? And in the example, we must have 2 points and a function. The function and 2 points must be given. Also the error, I mean the value of epsilon must be given also. That's it. The formula is this. Here we say xi plus 2 is xi times f of xi plus 1 minus xi plus 1 times f of xi, all divided by f of xi plus 1 minus f of xi. If we write down as x1 and x2, if we have given x1 and x2, okay, we say x3 is, could be obtained by this rule. It is x1 times f of x2 minus x2 times f of x1, all dividing by f of x2 minus f of x1. So it just works on the values of x1, x2, and f of x1, and also f of x2. So we need to first find f of x1 and f of x2 and plug those onto this formula. You get x3. You get x3. How to find x4? How to find x4? We use x2 and x3. Okay? How? We say the smaller one times f of the bigger one. Okay? I mean the next the one which has bigger iteration. Say x2 times f of x3 minus x3 times f of x2, all divided by f of x3 minus f of x2. Then for finding x5, so now we have x4 also. To find x5, what do? We use x3 and x4 and we apply the same. Okay, that's it. Look at this example. It says solve this function by using secant method. This function is impossible to solve by and finding the exact solution. So here we must use numerical methods. It's given that use secant method. Even if it's not given, it says if the initial guess are x0 is 1 and x1 is 0, 2 points are given. From these 2 points, we recognize that we need to use secant method. So what if an interval is given? What if we have this? What should we use? Can we use secant method? No. We should use bisection method. Bisection, which is the previous method. We must use bisection method for interval. For 2 points, we use secant. But for 1 point, we use the next method, which is Newton's method. We now have x0 and x1. And the function also. And the function as well. What we do first? We need to first find f of x0 and f of x1. To find x2, x0 and x1 is given. We need to find x2, then x3, then x4, and so on. Okay? What we do here, we say f of x0 is 1. Let's find it. It's given here that f of x naught is 1.1232. F of x1 is -1. Okay. As you see, it says do calculation correct to 3 decimal points. That means what's epsilon here? As it says 3 decimal points, means we have 0.3 O's, then 5. So epsilon is 0.30, then 5. It says 3 decimal points. Look, we found f of x0 and f of x1. How to find it? We just replace x here by 1 and by 0 to get these two values. You can use calculator to solve, to find these values. It's easy. Now, what we do? What x should you find? x0 is given. x1 is given. So what's the next x? Is x2. Okay? So what's x2? x2 is what? It is. It's x naught times f of x1. That's the smaller one times f of the bigger one. Okay, then minus bigger one times f of smaller one. Minus. Sorry. x1 times f of x0 dividing by f of x1 minus f of x0. We now find x2. We already have x0 and x1. These are given in the exam. And we also found f of x1 and f of x0. We just replace these all here by their values. We get x2 is, sorry, x2 is, x0 is 1 times f of x0. What's f of x? Sorry, x0, f of x1. F of x1 is -1 minus x1 is 0 times f of x2 is, sorry, f of x is 0. F of x0 is 1.1232. This is x0. This is f of x1. And this is f of x1. So this is x1 and that's f of x0. Then dividing by f of x1 is -1 minus f of x0 is 1.1232. Just calculate this. Just input this to the calculator, you get the result. Okay, let's see what you get. This is 0.471. So x2 is 0.471. This is x2. Now, we find x3. How to get x3? We need to use x1 and x2 to get x3. Okay? x0 was, here we have x0, x1, and we found x2. Then to get x3, we use these two, and we use the same formula. It's the same thing, but the numbers are changed. Okay? The numbers are changed. The same formula, and do this, the next iteration to get x3. After finding x3, then we will be continue till when? Here, this is x2. If f of x2 is less than epsilon, we stop. If not, we are going to continue. Then we find x3. If f of x3 is less than epsilon, we stop. If not, continue. Okay? That's it. This one is. Then will we continue for 3 steps? Yes. In the first, we have 1 and 0. In the second is the bigger one and with the next one. 0 and these two, and these two, and these two. Okay? We have these iterations. So after 4 iterations, it's iterations 0, 1, 2, and 3. So it's 4 iterations. For 4 iterations, we get that f of xi plus 2, f of the new x that you found is less than 0.005. Okay, I'll show you the triple O. Is it less than this? Yeah, 0. Okay, so it's less than the epsilon. Now we stop. So it's important to know where do you stop. Okay, in bisection method, which works on an interval, we say if f of c is less than the epsilon, we stop. If not, we continue. In this method, if the value of the new x is, if f of new x is less than epsilon, we stop. If not, we continue. In bisection method, we worked on an interval. But if you have 2 points, we use secant method. Okay? But for 1 point, we use Newton-Raphson method. And the example is the same as the above one. As you see, it says, suppose we wish to find the root for this function. A closed form solution for x doesn't exist, so we must use numerical technique. We will use x0 to be 0 and x1 to be this as our initial approximations, and epsilon to be this. Look, we haven't given that use that method, but you need to recognize it. We need to recognize it. We have given 2 points. As you see, we have given these 2 points. So only secant method works on 2 points. Okay? But if it's an interval, we use bisection methods. Okay? But here we use secant method. X0 is given, x1 is given. What we need to find? We need to find x2, then x3, then x4, and so on. Okay? If f of xn is less than epsilon, we stop. As you see, it's done here. This is f of x. It's less than, this is less than epsilon. Okay? Okay. Let's take a break for 10 minutes. We now have another method which is used for solving a nonlinear equation. The method is Newton's method. In this method, we just use a point. We just work on only 1 point. Okay? I just want to remind you that in bisection method, we need an interval. In secant method, we need 2 points to get the third one, and then the last 2 points to get the next point, and so on. Okay? Then for Newton's method, we just need 1 point. Okay? It works on only 1 point. How? Do you remember derivative of functions? Data شرطا بالماء. Okay. Because here we need derivative of the function. This is the rule. It says if you have xn, let's say x naught. To get x1, we say it is x naught minus f of x naught dividing f prime of x naught. And this is derivative of the function. In the derivative of the function, we put the point. We get a value. Okay? This is the rule for Newton methods. Okay? As I said, it works on only one point, and you should know what's the formula. For the next point, we say this. The given point minus f of the given point dividing by f prime at the given point. Look at this example. It says use Newton's method to estimate the root, even if it's not given. If it is not given. I've said estimate the root of this function employing an initial guess x naught to be 1. Look, we have only 1 point. Second method works on 2 points. Bisection works on an interval, but here we have only 1 point. So you should recognize that we need to use Newton's method. We need to use Newton's method. Okay. And it says do calculations in 5 decimal points. It means epsilon is 0.50, then 5. So 4 is 5. 5 decimal points. And obtain the solution accurate to 3 decimal places. No, it's calculation to 5 decimal points. That means in finding the values of, let's say, f of x naught, write down to us, let's say it's 2 points. Write down 5 decimal points. And it says, do the calculation for 3 decimal points. For 3 decimal points, so epsilon is 0.003. Let me check. Yes. 3, 5. It's not, it's an extra one. 3 zeros and 5. Okay? It is 3 decimal points. Look, our function is in all methods, we must have the function. We must have the function first. And also, in bisection, we must have an interval. In second method, we must have 2 points. And in Newton's method, we must have a point. Okay? And also, we must have the error, which is the value of epsilon. Okay? We must have the error also. Epsilon here is 0.0005. Okay? Now, to solve this, we work on only 1 point. Let's write down all the given information. It says x naught is 1. It's 1. And f of x, the function is x cubed minus sine x. Okay, and epsilon is 0.0005. We have given this information. Just by looking the given information, you should know that here we need to use Newton method because we have given only 1 point. If it's 2 points, we use second. If it's an interval, we use bisection. And we just have these 3 methods, no more. Look, we have given x naught. We need to find x1. We need to find x1. You see x1 is x naught minus f of x naught dividing by f prime of x naught. So from f, we need to find f prime. What's f prime of x? That's 3x minus cosine x. So is x squared. This is the derivative of the function. Okay? We use these two functions at all steps. And also the previous point also. To find x1, it is 1. x0 is 1 minus. What's f of x0? We just replace x here and here by 1 because x0 is given, it's 1. So it's 1 cubed minus sine 1 dividing by f prime of x0. x0 here is 1. We just replace here and here x by 1. You get 3 times 1 squared minus cosine 1. Calculate this. Let's see what we get. That's it. And this 0.9355. This is 0.93. Okay. It says calculated for 5 decimal points. So we need to write down 5 decimal points. Okay. When you use the calculator, it gives you 8 decimal points. Okay. Just choose the first 5 ones. Okay. This is the first step. This is x1. How to get x2? We say x2 is x1 minus. We just use the last point. F of x1 dividing by f prime at x1. We now use this function and this one and this point. We substitute this point into those two functions and put it here and here. Then calculate it. You get x2 and then x3 and 4 and so on. Okay. Then to get x3 is x2 minus f of x2 dividing by f prime at x2. Here we just need only one point. Look, these all must be the same. Okay, these all must be the same, and those must be the last point that you want. Okay, that's it. Now we get this table. We say if two successive x, their difference, I mean the length of two successive points. If it's less than epsilon, we stop. If not, we continue. Look here. We found x1. We say absolute value of x1 minus x0 is equal to what? If it's less than epsilon, we stop. If not, we continue to the next step. Look, let's say it is not less than epsilon. What we do, we find x2. Then we test x2 and x1. The last two successive points. We say x2 minus x1. If it's less than epsilon, we stop. If not, we continue. Then we get here. If it's not less than epsilon, we continue to get this. We say x3 minus x2 in an absolute value. If it's less than epsilon, we stop. If not, we continue. That's it. As you see, it's less than 0.3005. So you stop here. Okay? So no, it's not that. This one is. It's greater than the error. So we are going to be continue. This is the step, the first step. And then in 5 steps, we get the result. And this is F prime. And this is F. Okay? If we find the difference of these two successive X, this is X0, X1, X2, X3, X4. Okay? We say the absolute value of X4 minus X3. It is 0.92 0.92862 minus 0.92862. It's all 0. Okay? So you say we stop here. It's less than epsilon. And we stop here. Okay? That's it. It's less than epsilon, and we stop here. And you say the last value of X is our solution. What's X here? The index is 4. It's X4. So X4 is our solution. Okay? The last value of X is our solution. If in the previous method, in secant, it's the same. The last value of X is our solution. But in bisection, the last C that you find, the last value of C that you find is our solution. We just have these 3 methods. So the process is that we use this formula. And you have a point. To find the next point, we plug it to this formula to get the next point. Then we use the point that you found to get the next point, and so on. So we get that the length of 2 successive points is less than the epsilon. هتا كي هتا أو كاتب بردوامي كدو إكسي دوا بدوا يكليك در بكم لنا absolute value نرخ كيف سوتي بلا epsilon باشا epsilon خوي يعني برسيارك. That's it. أم تيبل أنا يبغى تيبل بيجن باشا بتيبل بيجن أسان ترابيز ناك أمام النوسين أنا هم كن أتوقع خوتان كالكوليتي كانوا يسبب النوسين تيبل كه ستيب كيبوبكا هاي ستيب يرفيد بوي كيف زين خلاص شونا ستيب كان يتر تيبل كيبوبكا هم يدوس أتوقع بكالكوليتر كهم حساب كده يسبب النوسين باشا أو أسان كاتان بوغرتو. Here's a special case of Newton's method. In this case, you can use the previous one, the previous rule. Okay? ليرة أما بجيب بيتها نعلم بلا أما اشتكي تايبته. هل يا ساقي بيشو بكاري؟ Okay? هل يا ساقي بيشو بكاري؟ هل نيوتن؟ Look at this example. Look at this. Here we have f of x is x squared minus 2. And it says x1 is 1.5. It is 1.5. Let me check. Oh, yeah, that's it. This is the table. The first x is 1.5. x1 is 1.5. Get x2, we say it is x1 minus f of x1 divided by f prime of x1. Plug it to this formula, you get value for x2. And here, this is f of x1, which is 0.25. What's f prime? It's 2x. F prime of x is 2x. If we plug it to here, we get 3. And this is 1.5. Calculate this. You get x2. And then to get x3 is, that's it. This is xn. This xn is plus 1. Okay. It starts from 1 actually, x naught is 1. Then x1 is 1.5. And so on. X1 is 1.5. How about x2? X2 is that. This x2. Together x3 is this. Now, subtract these two to get the error. If it's less than epsilon, we stop. If not, we continue. As you see, here, if we subtract these two, we get 0.007. It's greater than 0.0005. So we continue till we get a value which is less than 0.0005. Okay. This is, don't separate this from Newton method. You can just use Newton methods. Okay. اما وكو كيسي كي جاو سيدي مكان هاد نيوتن كا بكاري نيوتن هيك تر ام اشتقاق شيز نيه كشي نيه واسطه باشا. So this is the end of this chapter. Let's take a break. For next lecture, we start new chapter. We now have a new chapter, which is about eigenvalue problem. In this chapter, we talk about eigenvalue and eigenvectors. Okay. Here it says for a square matrix, so our matrix must be square. That means the number of rows is the same as the number of columns. For example, here we have a 2x2 matrix. Let's say A, B, C, and D. As you see, we have 2 rows and 2 columns. And even if you have a 3x3 matrix, let's say A1, A2, A3, B1, B2, B3, C1, C2, C3. As you see, we have 3 rows and 3 columns. The matrices here must be square. That means number of rows is the same as number of columns. It says for a square matrix A, an eigenvector and eigenvalue make this equation true. Here, A is a square matrix. V as the eigenvector. V is the eigenvector. And lambda is the eigenvalue. It says for a square matrix, if V to be our eigenvector and lambda to be the eigenvalue, this equation is true. That means if we multiply the matrix by eigenvalue, so by eigenvector, if we multiply the matrix by eigenvector, it equals to lambda times V. Lambda here is the eigenvector. So the eigenvalue times the eigenvector. V is the eigenvector and lambda is eigenvalue. These two must be equal. For a square matrix, here V is the eigenvector for the matrix, and lambda is the eigenvalue for the matrix. We will study how to find the eigenvalues and eigenvectors for a given matrix. Okay? We say if we multiply the matrix by the eigenvector, it must be the eigenvalue multiplying by the eigenvector. Okay, these two must equal. Here, it's an example. It says, for this matrix, this is the eigenvector. This is the eigenvector. It's given. Here, we say, the matrix, let's say it's A. A times the eigenvector, let's say it's V. A times V must equal to lambda times V. Lambda is eigenvalue. Lambda is the eigenvalue. V is the eigenvector, which is given. And also A is the matrix, and it's also given. It is given. Now, we say A is this matrix, which is -6, 3, 4, 5, times the eigenvector, which is 1 and 4. This equals to lambda times the eigenvector, which is 1 and 4. These two must equal. And from this, you can get the value of lambda, and lambda is the eigenvalue. That's it. It is 6 and 24. 6 and 24. Okay? Here, we multiply these two in the left. We multiply these two in the left, and we equal it to the right. Then we can get the value of them. Let's do this. Multiplying these two, we studied how to multiply two matrices. Our matrices are -6, 3, 4, and 5. This matrix A. We multiplied by the eigenvector. It's 1 and 4. Let's see what we get. Okay? We multiply the first row by all columns in the second matrix. First row in the first matrix, multiplying by all columns in the second matrix. And also, second row, multiplying by all columns in the second matrix. But in the second matrix, here we have only one column. We have only one column. This equals to. Let's write down as a column here, -6 and 3. -6 times 1 is -6 plus 3 times 4 is 12. Okay? We have, as we have only one column, so yeah, like this. Then we take the second row here, 4 and 5. We multiply by the second matrix, 4 and 5. 4 times 1 is 4. 5 times 4 is 20. This equals to 6 and 24. Comparing this is the left-hand side. This side is that matrix. And in the right-hand side, we have lambda times 1 and 4. We say 6 and 24 is equal to lambda times 1 and 4. So what's the value of lambda? Lambda شنو الخيك بيت؟ matrix که لای راستش اکاته 6 و 24. It should be 6, is it? So here, if we take 6 as the common, what we get in the left, if we take 6 as the common, I'm going to here. If we take 6 as the common in the left, we get 6 times 1 and 4, is it? It equals to lambda times 1 and 4. So what's lambda? 6. So lambda is 6. So we just use the formula. In the left-hand side, we multiply those two matrices and we compare to the right-hand side. And we get the value of lambda, which is 6. Okay? So here, lambda is 6. Okay? Here it says, let A be a square matrix of dimension n by n. That means number of rows and columns are both the same. That's 2 by 2, 3 by 3, 4 by 4, in any size. Okay? Let V be a vector of dimension n. And V also must be dimension n. Okay? We say the product Y equals AV. Y equals AV can be viewed as linear transformation from n-dimensional into itself. Okay? This is called a linear transformation. Okay? If V to be any vector in the vector space. Okay? V to be any vector, we get the same size of vector. As you see in the above, V here is 2 by 1. So what's the multiplication? In the multiplication, we get 2 by 1 also. We got this. Okay, we got the same size of matrix. It's just a note to know. Here it is what we studied before at the beginning. In solving the example, we used this. AV, A is the matrix, V is the vector, is equal to lambda times V. Lambda is the eigenvalue times the vector. Here, T of V, as we said, it is as a linear transformation. It's like a linear transformation. So it's A times the vector. Yeah, it's just nodes. Identity, okay. It's okay. Okay. Now, to find the eigenvalues, to find the values of lambda, which are the eigenvalues for a given matrix, we use this formula to find the eigenvalues of a matrix. To find the eigenvalues of a matrix, we use this formula. DET means determinant. Okay? We studied how to find the determinant of a matrix. Okay? Now, we say A is the given matrix, and I is the identity matrix in the same size of A. Let's remind you what are the identity matrices. For a 2 by 2 matrix, the identity matrix is this. Only the diagonal elements are ones, others are zero. Okay? For a 3 by 3, it's 1 0 0 0 1 0 0 0 1. Look, only the elements on the diagonal are ones, others are zero. Upper and lower are both zero. For a 4 by 4 matrix is the same. Okay, we just multiply lambda to this matrix and we subtract it from A. Then we find its determinant. That's okay. We equal to 0 to find the value of lambda. Look at this example. In this example, it says find the eigenvalues for this matrix. For this matrix, we need to find the eigenvalues. So what's the size of this matrix is? It's a 2 by 2 matrix. It's a 2 by 2 matrix. Okay, now we need to have a 2 by 2 identity matrix also. So what's I? I here is 1 0 0 1. We say A minus lambda I. We need to find this first. After finding this matrix, what we do? We find its determinant and we equal to 0 to get the value of lambda. Okay, we get a polynomial and it's easy to find the values of lambda. So it's important to know this rule. Okay, to find the values of lambda, we say determinant of this formula equals 0. Then we find the values of lambda. In finding the determinant of this formula, we get a polynomial. It's easy to find the roots of a polynomial. But here, we need to first find A minus lambda I. A minus lambda I. What's A? A is the given matrix. A is 3 minus 2, negative 1, 5 times, sorry, minus lambda times I. I must be in the same size of this one. If this 3 by 3, take as 3 by 3. If it's 2 by 2, take 2 by 2 identity matrix. Okay, it's 1 0 0 1, but you should know what's the identity matrix. I told you before, for 2 by 2, 3 by 3, and so on, only the diagonal elements are 1s, others are 0. Now, we enter this lambda into the matrix. It's for all entries, okay? It's for 1, 0, 0, 1, for all elements. We multiply all elements by lambda. We multiply all elements here by lambda. Okay, lambda times 0 is still 0. This equals to. Let's rewrite down the same. 3 minus 2 minus 1, 5 minus lambda multiplying by this matrix. Lambda times 1 is lambda. Lambda times 0 is 0. Lambda times 0 is 0. Lambda times 1 is lambda. Now we subtract this matrix from this. Okay, let's do it. 3 minus lambda, okay? 3 minus lambda, and then minus 2 minus 0, which is still minus 2. Negative 1 minus 0, it's negative 1. 5 minus lambda. This is a minus lambda I. Now we find the determinant of this matrix. Okay, we find the determinant of this matrix, and so det of a minus lambda I is the determinant of this matrix. It's a 2 by 2 matrix. In any 2 by 2 matrix, we said the determinant of any 2 by 2 matrix, A times D minus C times B. So here, 3 minus x times 5 minus x. Then minus negative 1 times negative 2. Okay, what we get? We get 3 minus lambda times 5 minus lambda minus 1 times minus 2. This equals to 0. We equal it to 0. So, to 0. Now, negative 1 times negative 2 is 2. And here we multiply these two brackets. We multiply this by both elements and this by both elements. Okay? And we get, after expanding these brackets, we get lambda squared minus 8 lambda plus 15. Okay, plus 15 minus 2. So we get 13 equals 0. Okay, now we solve this equation to get the values of lambda 1 and lambda 2. Here we get two values of lambda, sorry. That's it. This is the characteristic polynomial. It's called the characteristic polynomial. Okay? To solve this, you can use quadratic law to get the values of lambda 1 and lambda 2. Here we get 2 lambdas. For 2 by 2 matrix, we get 2 lambdas. For a 3 by 3 matrix, you get 3 lambdas. For a 4 by 4 matrix, you get 4 lambdas. And so on. And for this one, it's the same. We say B minus lambda, this matrix B. And it's a 3 by 3 matrix. So we need to take a 3 by 3 identity matrix. B minus lambda I. We just multiply this by lambda. Okay? And we subtract it from matrix B. And we get this. Okay? Then the determinant of this matrix, the determinant of this matrix is this. And this is called characteristic polynomial. This is called characteristic polynomial for B. To get the values of lambda, just equal it to 0. and find the values of lambda. Factorize and find the value of lambda. You'll get the result. Okay, it's enough for today. Let me take the attendance.